Hello everyone, and welcome to the string permutation solution lecture. So before we begin, what we're going to do is check out the problem statement. Again, there's a solutions notebook fully explaining the solution below, as well as a commented version of the code. Okay, let's go ahead and remind ourselves what the problem statement was. Given a string, write a function that uses recursion to output a list of all the possible permutations of that string. So for example, if the string is ABC, the function should return these 6 permutations of it. Now there was a special note here. If the character is repeated, what you should do is treat each occurrence as distinct. And what that meant was, if you had an input string of 3 x's, then you should get 6 versions of xxx. Alright, so given that, we want to fill out a solution below. Something I wanted to make note of, if the problem was just to permutate a string, you really wouldn't write your own function. In Python, you would use the itertools library. So I go ahead and suggest that you check that out. It's a really useful library in Python for doing these kind of operations. Okay, and it'll get you some bonus points with your interviewer if you mention that you know about it before you begin. So let's go ahead and look at the steps we're going to take to solve this problem. I'm going to zoom in a bit below. So there's 4 main steps here that we're going to use to solve. The first one is we're going to iterate through the initial string, so ABC. And that makes sense. In order to have any sort of permutation, we'll have to iterate through that string. Then, for each character in that initial string, so for instance, A and B and C, we'll set aside that character and then get a list of all permutations of the string that's left. So, for example, if the current iteration is on B, then we want to find all the permutations of the string AC, which would be AC and CA. Then, once we have that list from step 2, we would add each element from that list to the character from the initial string and append the result to our list of final results. So if we're on B again, we've gotten the list AC and CA, and then we'll add B to the front of those, resulting in BAC and BCA. And in each of those, we add to our final output list. And then we return the list of final results. So that's the main thinking we want to do. For each of these letters here, grab the rest of these letters and then see all the permutations of them, and then tack them on to that first initial letter. Now, hopefully you can see that this is starting to become a recursive problem, because if you have more elements or letters in that string, in a more generic term would be elements. So if you have more elements in that string, you could keep doing this for all those letters until you've come back recursively to that first initial letter. So to give you a better idea of what I'm trying to say here, let's go ahead and start coding it out. So first thing you want to do is just create the function. I'm going to call it permute. It takes in a string, and then I'm just going to say pass right now. All right. So in this case, what we're going to do, since we're going to output a list, it specifically asked for a list in the problem statement, I'm just going to make a variable called out and set it to an empty list. And let's think of the base case again. Remember, as we iterate through the string and go through all the elements, we know, similar to the last interview problem we just did, that the base case is going to happen when we just have one letter left, because there aren't going to be any following letters that we can do any sort of permutations on. So right off the bat, we already know what the base case is going to look like just by thinking about it logically. We're going to say if length of that input string is equal to 1, then we know out, we would just put that element on there. All right, now for the recursive case. So else. So what we want to do is, just like we were saying in those 4 steps, for every letter in that string, and I'm actually going to comment what we're doing in plain English. So for every letter in string, and in this case, I actually want to keep track, so I'm going to be using slicing. So I'll use enumerate. So I'll say for I, let in enumerate that string. Then for every permutation resulting from step 2 and 3 that we described, So for every permutation resulting from step 2 and 3, so that would be for, I'll say for perm in, and this is where the recursive call comes into play. For perm in permute, and I'm going to type it and then explain what I'm actually passing here. Let me go ahead and center that. Plus s of I plus 1 continued. I'm going to add it to the output. I'm going to say out equals plus the letter plus that permutation. And then finally, whoops, once that's done, I will return the output list. Okay, so base case should have been pretty straightforward. Once you have just one letter left, you just return that letter. Now else is a little different. So for every letter in that string, so what are we doing here? I'm saying using enumerate, I grab the index of my total string and then the letter in enumerate. And then for every permutation resulting from step 2 and 3, I'm going to add it to the output. So I say for perm in permute s, and s is going to go all the way from, oops, this should be I, excuse me, sorry, from everything up to the current index we're on here, plus the string from I plus 1 all the way to the end. So this is kind of tricky to understand, so I'm going to break it down a little further. So look what I'm doing here. I'm grabbing everything up to that index and attaching it to that index plus 1 all the way to the end. And so what that will do when I pass it into permutation, it will, if we go back to the solution notebook, you can see here it's going to basically say, okay, get A, and then pass that BC into the permute function, and then recursively keep calling it all the way until you only get a single element in that string. So your homework assignment, if you're having trouble understanding what the slice notation is actually doing in this permutation recursive call, go ahead and add print statements to help yourself really visualize this. So for instance, you can add print statements for yourself if you want to know perm is, you can add that, print, well, let's just go ahead and see what that will do if we run it that way. And then go ahead and run it on a very simple and obvious string like 1, 2, 3. And it'll show you the steps printed out for the permutations that it's doing. Perm is 3, perm is 2, perm is 2, 3, perm is 3, 2. And then since you're adding that to let, you can actually print that out as well. So we can go ahead and then put in, for instance, print current letter is LAT. And if we run that, we can say current letter. I should say element since I'm actually running numbers here, but I'll say ABC. So current letter is B, the perm is C, current letter is C, perm is B, current letter is A. And notice here, now we have the permutations we can add to it. BC and CB, which will end up being ABC and ACB, and that's going to be added to that out list. So use print statements to help you understand this. I know it's a little confusing if you just look at it at first glance, but feel free to print out as many of these things as you need to. You can also print out these specific index slices to help you really understand how these recursive calls are working here. Okay, so that's it for the solution. Remember, you can read the entire solution notebook for a deeper view of how it's actually working. But all we're basically doing is going through the iteration of the string. Then for that string, we take off an initial letter, look at everything else, and then find the permutations of it. In which case, if we do this recursively, we'll take off that initial string and then find the recursions of that. using that slicing notation we did earlier. All right, so go ahead and walk through the solution and make sure you fully understand it. And other than that, I will see you at the next lecture. Good job, everyone.